This meeting
Okay, so if you want to watch the video in the past, then you can click on Visual Student Service Support Center here. No, that is not the one we want. Lecture video. Okay, then you can go to Phone 2020. The first one we get, that one, the second one here. Okay, that's how you can get to we study on the video. We already did it. Okay, so today we will go with the e-review 1. Did you see the picture bigger or smaller?
Small bigger, more bigger.
Okay. Is that the big one?
Yes, it's okay.
Okay. So that is try to review at the beginning up to today for the DC. We're supposed to get today as much as we can. Okay. So they're talking about resistor here. Series resistor, R1 plus R2, R3, go up. And if you get the only two resistors in parallel, then R total will be R1 times R2 divided R1 plus R2. Okay? The application for the resistor will be adjust the current flow, adjust and divide voltage level, or terminate the transmission line, a bias, active component. And the Ohm law, we already know the Ohm law. V equal I times R. I equal V divided by R. And R will be V divided to I. In this formula, V must be in volt. I have to be ampere. R have to be in ohm. If it's not, then you need to conversion. Okay? And also the power dissipation. You get three formulas to calculate the power. V equal V times I square R, or V square over R. And the power will be in watt. Okay? V have to be in volt, I have to be an ampere. If you get any question, stop me, okay? We don't have any more chance to going back. Okay. KCL, Kirchhoff current law. At any node or junction, the sum of current flowing into that node junction equal to the sum of current flowing out of that node and the junction. And the Kirchhoff voltage law, KVL, the sum of voltage drop around any closed loop must be equal 0. Okay? Now, what I want you to do, try to tell me what the answer for this thing. They want to determine following quantity for each of the two resistors shown below. Okay, what equivalent? Current from the power supply. The current flow through the each resistor and the voltage drop across each resistor and the power dissipated in each resistor. Okay, quickly, I can give you the answer, okay? I think we don't have enough time to let you guys do it. The first one, you adding up, you get 100 ohm.
Thank you for that.
Yeah, if you want to talk to me, just turn on your microphone. Okay, any question? Are you done for your copy or not? Let me know so I can move to the next one.
Not yet.
Are you done?
Yes.
Okay. Okay, law, V equal I times R. What will happen to the current passed through a resistor if the voltage drop across it is double and the resistance is a half? L, B, or C, or D?
Can you come back again?
That means multiple choice.
Will it be the same?
L, B, or C, or D?
B.
A.
If the voltage drop double,
4 times.
double means 2 times. I believe that will be C.
A.
C. Cannot be the same.
Drop. C.
Is it B?
I think that will be C. Half.
No, it's D because you're doubling the voltage and half the resistance.
Isn't the voltage dropped by half if the resistance is just normal?
Voltage drop is double,
And-
Right,
2 times.
Right.
Right.
And the resistance is half.
And resistance is half. Is it right or wrong? Okay.
So it's 4 times.
D.
Okay.
The question
so,
is, the question asks, what is the current?
so that means in D.
No, they're asking for what with the current.
If the voltage drop across is double
Oh, okay.
and the resistance is a half,
Yes.
that means voltage double divide 0.5, that means a half. Then what happened to the current? Current will be 4 times.
Could be
Right.
okay.
So the answer will be D. Okay, now on that one, I not try to stay for your guys calculation. Take for a while. However, I want to explain to you the way how we can solve the problem. The first thing you look into the circuitry, 8 ohm and 8 ohm parallel. You can combine to 1,
4.
right? 8
4.
times 8 divide 8 plus 8.
That's for ohm, no?
That's why you get 4 ohm.
4.
Then this one 4 ohm will be series with 6 ohm. You combine it,
10.
Okay.
right? Then you can get 10 and 10 in parallel, right?
Mm-hmm.
So that's why
5
you get 5 ohm. Okay? So now you get 5 ohm will be in series with 1 ohm and
Mhm.
3 ohm. You want current, total current here. 9
1
divided to 1 plus 3 plus 5. Total resistance is 9. Okay? I equal V divided R. 9 divided 9 ohm. So that current will be 1 ampere. Okay. I joule equal 0.5. If you get a question, just bring it up.
So
Otherwise,
for, yeah, I have a question. So for
Yeah.
for this example, you're saying essentially to the smallest circuit there for the ohms. I'm sorry, for the resistors to
yeah,
find out those first, and then the next series there, and then the total one.
right.
If that
First
makes
thing
any
you
sense.
want to calculate the total current I here. Then you
Right.
have to combine everything here
Okay.
and here. Okay.
Okay.
So that's why you get 9 ohm.
So you're doing like the smaller parallel circuit first,
Yeah.
and then
you
the
have to
medium
go
size, and then overall. Okay.
right. Step by step. This one parallel, you get one. Adding to 6 ohm, you get series. Then they parallel with 10. Then that will be series with 1 ohm and 3 ohm. That's why you get 9 ohm.
Got it. Okay. Thank you.
Any more? The thing is, one thing you have to understand is we don't care much about doing calculation. Why? The thing is, you wanted to run simulation. You get everything you need. Why we have to do calculation? Okay? But you must be understand very, very basic. Like, two resistor in parallel, you can combine by the formula R1 times R2 divide R1 plus R2. Okay? Now, on that thing here, we need to do find the total resistance. Okay? This is a series circuit. Go ahead and tell me what value you get.
Five kilo.
5 kilo.
5K.
5,000 ohm.
5,000 ohm or 5 kilo
5,000.
ohm. Either way. Okay? Then they find the current.
Two.
You take the voltage divide to total resistance. And they wanted to be in milliamp.
Two milliamps.
2 milliamp. Number 3. Write the formula to calculate VB using voltage divider law.
PB.
That means they want to calculate the VB.
4,000.
Normally you do it. You already get a current here. And now from B to the ground, you get 2 resistor. So basically, you can take I time with the R2
R2 plus
plus
R3.
3. That's normal. However, I want you to know the voltage divider. Okay, now you see the formula. Voltage divider means you can take the voltage here time R2 plus R3. Then you divide R1 plus R2 plus R3. The thing is you're using the voltage divider, you don't have to calculate the current. You see that?
Yeah.
Sometimes they not given asking you the current, you don't have to calculate it. They want voltage divider. Okay? And 5 VB using a both circuitry 8 volt. And now they want VC. That means from C to the route. They will be I times R3. And now they want to find the voltage VBC from B to C. Basic formula will be VBC equal VB minus VC.
Minus VC.
VBC means the voltage across R2. You can calculate by VR2 equal I times R2. They will be the same. Find power dissipated in R1 in milliwatt. Okay, I need someone tell me the answer.
Studying to do.
The formula will be drop
I squared
voltage
up.
time the current. So
I square times R1. Who
Is
get
it
the
4 milliwatt? 4 milliwatt?
will say
Oh, okay.
4 milliwatt.
Something got a little bit like disconnected that probably dropped it.
Uh-huh.
So it's gotta be like.
Perfect. That's fine.
Hey, Mr. Pham, would that also be V squared over R?
Yeah, same. Depend on whatever you get. V square over R, right?
Right.
V square have to be VR2 square. Divide to R2. You're supposed to get the same answer. Okay? Question.
Okay.
Easy, right? Now, that's what we want to talk for today. What we call a superposition theorems. What we're using for? Using to solve any circuit with two or more voltage or current source. Now, if you get a E1, E2, that means two voltage source. Okay? Keep one source while remove on up the other source. That they telling you you only working with one source at the time. Only working with only one source. Now, if I want to keep E1, then I have to remove E2. The law will be to remove the voltage source from the circuit. You must be shorted, just like the wire. Okay? And if you want to remove the current source, then from circuitry you must be open. Okay? Do the calculation for each circuit and add up for the results. Like I want to calculate the VB. Now, first thing I say, I take 40 volt out. Then I calculate VB1 for this power E2. That's done. Then now I have to remove E2 and keep E1. Then calculate VB2. After that, I adding up VB1 and VB2. That's what I get VB. Okay? So now in this case, they say, I want to remove E2. Now, this is they not display for me. Okay. This is remove E2. I remove this one. So you see sorted. Okay. What I need to do is calculate the VB. Can you tell me what VB1 equal? Better using voltage divider. VB here to the right.
Over 10.
So you take E1 times R2
20.
by R1 plus R2. That's why you get 24 volts. The next step, I want to remove E1. So I short it. So if I want to calculate the VB, what VB equal? If you want to calculate the VB2, then you take 20 volts times R1.
Is it 8?
Correct. You see that? That's how do we calculate VB2. And after that, you add them up. And VB equal 24 plus 8 volts, you get 32 volts. Okay? So basically,
Okay.
this is engineering level. If you go to the college, you go to the university, you must be learned. For the technician, never they asking you to doing calculation. They just asking you what we using superposition theorem for. Then the answer will be when you're solving with a circuitry with two or more voltage current source. Then we need the superposition.
क्या?
Yeah,
हाँ?
is it right?
क्लोज कर देना
हाँ. क्या करते हो?
खाना बना के खट
कुछ नहीं हो रहा, तुम पूरा करो.
Mute the mic, mute the mic.
Oh, sure. New, too many things will be new.
Yep,
Now,
just mute the mic.
really not easy. Any question on this problem here? I said if you not quite follow it, please stop me, okay? You'll be here try to understand. We try to give you a very basic for knowledge about electronics. Okay, no question. We go. Now you do for me. Ha. I want to see how many people can do. I already teach you what need to do. You get two source 2 ampere, 110 volt. They want you using superposition calculate VR2, the voltage here. So you have to remove one source and calculate the VR2. Then you remove another one, calculate the voltage across R2, then add them up. Basically, you want to calculate the VR2, you need to calculate the current go through R2.
So we have to do.
Voltage divider either way.
So what we can do is get the equivalent resistor from R3 and R2. That's the first step, right?
Yeah. You have to calculate VR2. In order to calculate VR2, two ways. Calculate the current, then current times R2. Or you can using voltage divider. But the first thing you have to remove one source, working with only one.
Hey, Mr. Pham, up top it says remove the 10 volt source. So
That's okay.
I know, but I'm just saying, I'm repeating what the other student was trying to ask. So you short out that 10 volts, and then you parallel the R2 and R3 and get the equivalent resistor, and then you add that one to the 50, and that'll give you the total resistance.
Okay, so I was right? Okay, thank you very much.
Look like you're doing okay. Get from me. Okay, that one they will be shorted, remove 10 volt. So you get current flowing here, one going down here, one going down here. So your job is calculate I2. How? If I look into the circuitry, I know for sure R2, R3 in parallel. The thing is you get I2 and I3. Different current in parallel. How do we calculate I2? What formula?
Current divider.
Current divider.
Thank you.
Now I see. This is a current divider. I times R3 divide R2 plus R3. You get 0.4 ampere. I mean I here. That's the current divider law. You don't know. Then now you have to know. And VR2 will be equal 40 volt. So sometimes for microphone problem, I didn't hear the people want to asking me. Who knows? Try to repeat it for me. So on the first one, any question? If it's not, now I remove two arms. See that when I remove current source, they will be open. So I want to calculate the VR2. How do we do it? Using which way? Better way.
Voltage divider?
Exactly. That's what I wanted. Voltage divider. You take 10 times R2 divide R2 plus R3. You do nothing with R1. Why?
Because the circuit's open there.
The
Apply
thing
no
is they
voltage there.
open. Current not go to R1. They go to R3 and go to R2. Not go here. They open. Okay, so VR2 equal 10 times 100 divide 100 plus 25. You get 8 volts. And finally, you adding 2 voltage for VR2. 40 volt plus 8 volt, 48 volt. If you're still confusing, okay, anything, just bring it up. So we have to understand.
It's just a matter of practicing, but the time doesn't let me follow the speed of everybody else.
บอกว่า make sure you copy the answer and try work it again to make it more clear for you, not only one time. Normally take about a couple times in order to understand. Okay, we're done. Go next. Now, they're talking about another one. Thevenin theory. Only thing you have to understand what the Thevenin doing. Okay? Now, what they want to do, any source and a component, no matter how they are interconnected, can be represented by an equivalent only one source and one resistor. that source will be V Thevenin, TH, and the resistor will be R Thevenin. Okay, so on this circuitry here, they get 1, 2, 3, 4 resistor or more, doesn't matter. But what they want to find the equivalent circuitry with only one source and one resistor. That's what the V Thevenin and R Thevenin. Okay, now, first step, what I want you to do, to calculate the V Thevenin, you must be remove the load. This is the load right here. You understand that what that means for the load? That means they not depend on the setup. I given you the example. In your amplifier at home, one thing will be the load. Which one you know? That will be the speaker. The speaker is the load. Why? You can change any speaker you want. However, you cannot change anything inside the amplifier. Okay? So the load is not go with the setup. So the first thing you want to calculate the V Thevenin. You remove that one right here. You remove that one and you're looking into the circuit. Okay? Any voltage across the open resistor here. That means the voltage from here to here. That is V Thevenin. So if I want to calculate the VR2, how do I calculate it?
Voltage divider.
Very good. You want the VR2. That will be the same V Thevenin. You take 20 times R2 divide R1 plus R2. Nothing to do with R3. The thing is open, so no current flow here. Okay, so V Thevenin equal E times R2 divide R1 plus R2. That's why you get 11.1 volt.
Would an LED be considered a load?
And now, you want to calculate the R Thevenin. Then the 20 volt here, they must be shorted. Okay? To calculate R Thevenin, remove on source, then calculate R Thevenin across the open circuitry. That means you remove that by sorting. Then now if you're looking here into the circuitry, that means you assume current flowing here. Then you can try to see which one serial, which one parallel to calculate the combine. Okay? So if you get the current flow from here, you can see one go R1, one go R2. Then you can combine R1 and R2. Then you adding R3. That means you get R Thevenin. If you see I doing calculation here, R Thevenin, R1 parallel R2, and then series with R3. Okay? You calculate, you can get 3.2 kilo ohm. Okay? After you're done, Now this is the circuit you're supposed to get. 1 V Thevenin 11.1 volt. 1 R Thevenin you get 3.2K. Then now you can connect the load into that. Easy for you to calculate the I current flow. Okay, you can take 11.1 divide 3.2 plus 1.1K. That's what you get the current flow here. If you want the voltage for the load, you take that current times RL. Okay, so any question for Thevenin?
Is there any advantage of using any of these theorems against Ohm's law? Is there any specific use for each and every one of these, or can we choose?
Well, they still
whatever?
using Ohm law everywhere. However, they did try to do is you get a circuitry with too many resistance or different source, and they want finally only circuitry very simple, only one voltage and a one resistor. That's what Thevenin for. And if you want to measure the current, easy to calculate it. You want to measure the voltage over the load here, easy to measure, easy to do calculation. Okay, this is the way what the Thevenin try to do. Again, you get a complicated circuitry here. You want to calculate the load here, take a lot of time. Okay, so that's why Thevenin he will be help you. Try to make the circuitry more simple. Then you can measure the current flow in across through the load.
Just as a house cleaning message to R1 should be 1.2 kilo ohms.
You mean for which one?
He's referring to the first circuitry, the R1 right there.
Yeah.
The first circuitry right here on the left side. Right there, R1, that's supposed to be 1.2 kilo ohm, not 0.2 ohm.
That's a, yeah, kilo ohm, I'm wrong. Okay, just change it to kilo ohm.
It's that way on both sides. But in any case, my question was, the main thing is on the, when you're going after the V7, you take out the R load and you disregard the R3 because it don't look like R3 is a part of the equation. Is that correct?
When you take out the load here, right?
Right.
Okay, you're looking here. When you take out the load and you're supposed to get the current flowing from 20 volt, right? Right here.
Okay, go ahead.
They not go here.
Right.
The thing is open. Okay? So the
let me ask you this, Mr. Pham. If you were to put the black lead on the ground, put the black lead on the ground and the red lead above on the right side of R3, R3 wouldn't look like a resistor. It would look like just a plain wire or what?
No, just a resistor. If you measure the voltage from here to here, what you supposed to get?
0 volt?
You will be get the voltage here.
0?
No. You get the voltage here. If you get
okay.
If you get 5 volt here, that have to be 5 here.
Yeah.
The thing is current is 0. No voltage drop here.
but I guess what I was trying to ask is, since no current flows through that R3, R3 is almost like a plain wire or something, right?
You mean a plain wire?
In other words, it's almost like the resistor doesn't exist.
It's a short circuit, just like
Yeah,
a short.
look like they're not there.
Yeah, okay.
The thing is, current not flow through it.
Just
Yeah,
no
right.
current.
Right. Okay. Thank you.
Yeah.
Thomas, but you. Sancho.
No more?
So effectively, that would be considered like infinite resistance.
Which one?
The one you was
Exactly,
talking about.
yes. It's
Yeah.
an open circuit.
Yeah, in an open circuit.
Yeah.
It's an open circuit, infinite resistance, exactly.
To do. Open the load, that means open right here, right?
Right.
Yeah.
Then you want to calculate the voltage from here to here. The same, the voltage from here to here.
Mm.
At that only thing
Okay.
to calculate the V Thevenin
Okay. I got you.
and calculate the resistance.
I got you.
They already here. Source must be removed. So they get a voltage, you sort it.
So basically, there's no current running through that voltage drop. But if you were to connect both ends, let's say like a car battery, you would actually get 11 volts drop or increase. And you could actually start getting the current flowing if you were to connect both ends into a circuit, correct?
Right.
Okay.
Okay. Now for calculate the R Thevenin, you sort that guy. From open here, you assume current from the open going in. Try to find out which resistor in series and parallel, then combine it. Okay? So you can see R1, R2 in parallel and series with R3. You add them up. So that's why R Thevenin here.
All right.
Now you do this for me.
Uh-oh.
I try to see how much you understand. Anyone can get the right answer for me. They want R Thevenin. V Thevenin.
Mr. Finn?
Yeah.
I was just letting you know I have that circuit drawn if you want the students to see the current flow.
Okay, so let's almost done for this review. Then I can let you share the screen. The thing what I'm saying is try to understand what they try to do. And you never have to do it. The thing is, you get a piece by simulation. You don't have to do anything. You run the simulation. They're telling me on up the voltage and the current. You need it. But for the knowledge, then I asking you to understand what we're using Thevenin for. How do I calculate the V Thevenin? How do I calculate the R Thevenin? But you don't have to do any calculation. The thing and the thing in the field they can ask you. So that's why I want you to know.
Thank you.
No problem. That's my job. First thing you want V Thevenin. You remove 1.8K. That's why you get V Thevenin. Easy.
Is V7 in 12 volt?
That the circuitry will be look like. V Thevenin 12 volt. You understand it? Very simple, easy. Thevenin.
$1.8.
Right, you get it. Here, 1.8. And they using the Thevenin to calculate I in load. That means the current I here. So I load will be V Thevenin divide R Thevenin plus R load. You get 3.33 milliamp.
How did they get the 12 volt Thevenin?
You mean the 12 volt
Yes.
here?
Mm-hmm.
How do we get the 12 volt? When you take that out, right? So you want the voltage across R2. And that's the 20 volt. No current flow to R3. Forget that R3. So voltage divider. You take 20 times 1.5. Divide 1 plus 1.5.
Wouldn't it be divided by 2.5?
20 times 1.5 divide to 1 plus 1.5.
Right, 2.5. Okay.
Okay, if you done on number 1, number 5, now you do it for me number 6. Only difference they using a negative 18 volt. So we want V Thevenin and R Thevenin.
Is it V Thevenin negative 4.4?
We'll see. 4.4, correct. You're good.
Is it going to be negative or just 4.4? Because you have changed the polarity of E.
That you see, I draw it negative here mean minus 4.4.
Okay. Got it.
If we connect negative, then we don't have to put a minus.
Okay, thank you.
You're welcome. And if you want to calculate the R Thevenin, you remove that one here, and the current flow through here. One go here, one go here. You sort this guy. So basically, they just R1, R2 in parallel. That's what you get, 16.62K. The formula will be 68 times 22 divide to 68 plus 22. Okay, then now you can calculate current easy. I load equal 0.203 milliamp.
I got R Thevenin 16.62.
16.62 KO.
Yeah. Kilo.
Perfect. Yeah, correct. Basically, for that superposition and the Thevenin theories, if you not understand, that be fine, no big deal. That for the college or university. For technician, we just know what they're doing, but you don't have to do any calculation. Okay, any more questions on that tape? If not, try to see what night, no more.
Wait. Can we get that page again one more time? I'm sorry.
Oh,
Thank you. Sorry. Okay. Yeah, verified it.
okay.
Yep. Thank you.
Now, if you, first thing, if you want to drop out of the program, just email to me. Okay? Basically, in the Zoom, it's hard to see too many people. We don't know who. However, basically based on the assignment, you're missing Zoom, that's okay. But assignment, you must be uploaded. Okay? We be on that. The thing is, what I'm saying is, I get the total student in this program. Take 1 and 2, 140 students. And now I see the people show up in around 95. About at least 40, 50 students, where they go. Okay? So again, what I'm saying is take 1, take 2, where we get a Monday and Tuesday with my Zoom in electronic. Okay? On Wednesday, Mr. Tai will teach you guys about the left bone. And Thursday, you can get a review on the whatever I teach you guys. And also teach you PSPI simulation. So now you're not doing anything with the PSPI until Thursday. If you already know, you can do. Okay? So on Wednesday, I teach textual digital circuitry. And then I will be allowed any student from Tech 1. If you already know how to working on the level, you already know how to doing PSPI, then you can go to my web on digital. You can learn in advance, okay? And if you can do, you can keep doing the homework also for digital. That will be in the future, save your time, okay? That means later on, you only need to collect enough hours for the program, then you will be completion. Okay, I don't want you already know the level and you still have to stay there. No, you already know it. Go into digital to learn more things. Okay, and any question?
Are you ever going to go into Multisim 7?
Multisim 7, no.
How about PHET, P-H-E-T? Are we supposed to be doing anything with that or the simulation?
You mean FET?
Yeah.
That means the FET.
PHET.
JFET.
Yeah.
Right. We do everything.
Okay.
That means you have to do on the left phone for JFET, okay? And you have to do simulation for JFET, and you have to do homework assignment for JFET.
Mm-hmm.
Okay? So any more questions? Okay, anything else confusing about the program, just bring it up. What I want to tell you, this is a very, very good time to learn about electronic and digital. If you want to moving up, okay, to be a technician, then you have to get a very basic understanding.
Mr. Pham,
yeah.
Just want to clarify. You're saying I did the summer one, so you're saying that for Thursday, where Mr. Tai is going to be teaching about the
PSPI.
If I don't want to join that class, I can actually join your the other class for digital. Is that correct?
Yeah, you can go by digital mean on Wednesday. I'm not teaching Thursday, Friday.
Uh-huh. Oh, yeah, Wednesday, I mean, yes.
Wednesday.
Yeah.
All the Taekwondo will be welcome if you want to learn digital.
Okay, now would that be only for this week or for
the rest?
For the rest of the semester? Yeah. Okay, all
the
right.
Thing is, on the Wednesday, Thursday, they can review what I've been teaching you guys.
Okay.
And also teach you guys about PSPI. If you already know how to do it, you can do your homework.
Right, and then
okay?
also.
And the level, you already know how to using the equipment, how to set it up or measure, then you can be okay.
Okay, I appreciate
However, when you take on the digital, and also you can get assignment for TechQ. Try to do as much as you can. Then later on, you don't have to do again.
Okay. All right. I appreciate it. Thank you.
Yeah, that is the way we're supposed to do during the online.
Michael?
Yeah?
Could you please explain me what the professor said? It's just that I don't speak English very well, and understanding his accent is really hard for me.
Have you done summer Tech 1?
No.
No, then all you do is for this Wednesday and Thursday, you go to join Mr. Tai, and he will teach you about PSPICE and lab. So no, just disregard what he said about digital.
Okay.
All right.
Yeah, basically the new technician coming this fall. Then you will be go to Mr. Tai on Wednesday and Thursday.
So just to clarify things up, so for Tech 1, it's just going to be Wednesday, Thursday?
On Mr. Tai.
on Mr. Tai. But tomorrow there's a schedule where it says Tech 1 and Tech 2. Are we who are Tech 1 attending that class too? Oh,
Right. Tomorrow
okay.
still electronic for Tech 1 and Tech 2.
Okay. All right. Just to verify it. Thanks.
Yeah.
So
Anything
we have to attend pretty much every single day, right? From Monday to Friday.
So Alberto, if I'm right, for Tech 1, if you are in Tech 1, you still have to attend the on the schedule says. It says Tech 1 and Tech 2 Monday and Tuesday, and also Wednesday and Thursday as well. That's what the schedule, and that's what I had verified to Mr.
Yeah, just reading on the website.
Okay, so let me check the website just to make sure that I understand everything. So it says home. So I have to attend because I'm on Tech 1. I have to attend on Monday. I have to attend on Tuesday. I have to attend on not Wednesday because it doesn't say Tech 1. It just says
No,
Tech 2.
Wednesday and Thursday as well too for Tech 1.
Okay.
Come every day.
Pretty much every day, right?
Friday, Saturday, Sunday.
There's two different links for Tech 1 and Tech 2.
Monday through Thursday. Monday through Thursday. Everything. Monday through Thursday.
Wait. One quick question. So are there two separate sessions, different for the same thing, or?
Yes.
Oh.
If you're looking at schedule here,
Okay.
say that Tech 1 and Tech 2.
Okay.
Go to this Zoom.
Okay.
Tuesday, 1 and 2, go to this Zoom.
Okay.
Wednesday on the Tech 2, go to this Zoom. Also Wednesday, Tech 1, go to Mr. Tai Zoom here. And Thursday, go to Mr. Tai here.
Oh, now I got it. It's just that on Wednesday you have two separate links. Okay, I got it. Thank you so much, and I'm sorry for interrupting.
I think I did then every week. Friday will be no meeting.
Okay.
Okay, any more questions? I said if you're not in the Zoom, okay, and you need to see it, you can go to lecture video. Go into here, and you can see that my first lecture, that's the second lecture. And today will be upload today's lecture, okay? Only thing we need your assignment to upload.
Okay.
Okay, for about few weeks, I didn't see you upload anything. Then now you not drop, I drop you. Okay, so Mr. Lowe, you can share something.
That's what I wanted to make sure. If you wanted them to know what circuit simulations are available, I still have that Falstad. That's the one I play with, just because it shows the current flow and has some basic components. So if you want me to, I'll show something very simple real quick.
Yeah, very quick. I still need some help.
All right, hold on. This is one of the previous schematics that we were looking at. Just
Quick
verify
question.
the
Friday.
Just look at the numbers on the schematic. Hold on, I'll be sharing it.
The Friday class that we had with Tony, I guess, Tom, that actually will be on YouTube as well.
Mr. Pham, you have to enable sharing. Mr. Pham.
Yeah.
You have to enable sharing.
Let's see. Okay.
All right, so this is a basic schematic that we were looking at. So that's basically the same results that you calculated in the previous circuit, and breaking the circuit for a disconnect, and then you had the 11 volts, 11.1 as your value. That's just a very basic circuit and how the current flows. So that's a visual of something to help you try to understand basic current. Now, like say if I go back and I add the power source back in, you'll see the difference in what this schematic originally looked like before you started removing components. Each component has the ability to be removed. All of them have the ability to be removed. They have measurements that you can set. Each circuit, you can display the numerical values. Each component, you can set their resistor values. And you have a nice list of components that you could add, like say a switch. You want to take away the power supply. And put a switch in. So there's different ways to break your circuit.
Sweet.
When the schematic is being taught during your Zoom.
Was this a Spice?
No, this is called Falstad. Falstad.
Okay.
One more time, how do you spell it?
Falstad.
And is that available for Mac users? Do you know?
You would, again, I would have to say no, because I haven't done enough research to verify that question for you.
Okay. Do you know any
for you
secret
on
simulator?
For you on a Mac, the only thing that I can understand that's going to help you is install your VirtualBox. Once you install your VirtualBox, then you have the ability to run various software in Mac. So
What
if you
is
want
VirtualBox?
to run, if I remember right, Mr. Tai was saying you have to load VirtualBox to run PSpice. So you're gonna have to load up VirtualBox and then follow how to make sure that gets loaded properly. And then you should have plenty of options to use as far as software. You should be able to put PSpice on your Mac. All right, one last thing.
But what is VirtualBox? Is it some kind of a software, additional software that I need to download in order to be able to install these simulators?
VirtualBox, Virtual Manager, it's an application that allows Mac and Windows to be versatile, have the ability to run multiple softwares, has multiple abilities to run compatibility mode for software, for both Windows and Mac. But
I'll Google about it.
So to have it loaded up correctly on your Mac, that's something you're gonna have to research. Just go to VirtualBox, and they have instructions there for you. All right, one quick last thing here. The last circuit that we were using had a voltage source on this side, and then over here you had a current source. So you do have the ability to design the circuits almost the same as what the instructor is showing you. If you want to try and keep up with the class and draw your circuit, then that's something you're gonna have to challenge yourself to. But I'm only listen to what the instructor wants you to do. I'm just showing you something that visually helps for me. All right, so that's it, Mr. Fran. Thank you.
Hey, what software you using?
That's Falstad.
.com?
Hold on, I'll type it out real quick.
The link is in the chat box.
Just a minute. I need to write down. Let's see. For state.
When you first originally start the program or you go to the website, you're going to see a circuit pop up like this. And then you're going to have the start of the original circuit program. This is what you're going to always see when you first start up the website or you log on to the website.
Is it you have to pay anything?
No, it's free.
Okay.
This was one of the original links that ETT had in the websites for reference, Mr. Fran.
Okay. I will talk to Mr. Tai.
Can't see the screen though, I guess, if you're trying to type.
That's a very good tool to
All right,
learn.
hold on a minute. Let me make sure you can see that again.
Thanks.
You see it now?
Yeah.
All right, so that's like the original load program that you're going to see. But you have to understand something about this website. Over here on the left, you have import and export. If you want to save this program, you export it as a text file. So you copy that program here in this box. Then you open up Notepad and you paste it. And you save the Notepad file. So the next time you want to load that particular schematic, you go over here and you import from text and you paste that program back in and it'll redraw it for you. But you have to be careful. You have to save your schematic every time, because if there's the slightest interruption, I'll show you. All right, this is if you can't see it, that's all right. Hold on. I'm going to copy a file, and I'm going to show you how it will change. So you should see 2 resistors, a capacitor, an inductor, and a power supply. I'm going to import a file. So I'm going to import, and well, it didn't work. Hold on a second. I'm importing a file, better work. All right, there you go. So the text files work. You just have to make sure you save your schematics. You can save it as a text file, or it will allow you to save it as a link. So there's 2 ways to help you with your files. I find this program to help. It visualizes and provides you basic information. Here's one thing too, is I I can turn on the scope and I can highlight each component. And when I highlight a component down on the lower right, it provides me the value of your voltage drops, your current, and power moving through that component at that particular time. So that's, I have the power supply highlighted. So if I go up to the resistor, it shows you power consumption, voltage drops. Each component is going to display its own value to the lower right. So use it. I use it mainly for cross-reference, checking your formulas. So I'm sure it might help you.
What are the main things you have to do when you first come on the thing? What are the 2 or 3 main things you have to do?
Determine your schematic. Get a couple components. You can choose your components. If you know your shortcuts, you can draw quicker. Your shortcuts will help you drop your components faster. Same with wires, you can draw faster. That's when you know your shortcuts. But the draw function.
Okay, so you know all of that. Then what do you do just to get it running?
You want to get to the website? You want me to show how to get to the website?
No, just explain. Once you've already drawn it, then what do you do?
All right, I understand. Hold on. So going back to this circuit, hold on a second. This particular circuit, once you have it initially drawn, that's what you see when your whole circuit is selected and you can move it in pieces, right? So right now I have my circuit drawn and it doesn't show any errors. Up here in the top right, you have run and stop. So while you're building, you can stop your program, and when you're ready to run it, it's basically simulate. That's how you get your program running. But if you don't make a connection correctly, let's see if I can make a connection here wrong. You'll have an error come up, and it'll tell you basically what's wrong. And if you can analyze your circuit correctly, you can make the correction. And it'll stop running. That's technically, you're frying your board, you're cooking your board, or you're smoking your board. So fix your problem. So all you got to do is just hold on. You got to take the components out. Select them, get rid of them, and then you're able to run your program again. So it shows errors when you do something wrong. You can speed up the current, slow it down so you can see how the flow is. And the same with the simulation, you can slow things down. You can even have you can put what's called a slider on it. And I'll tell it that I want it as a resistance value. And technically what I've just done is I've turned that resistor into a potentiometer. So I could go over to the slider and change the value. You can do that for every component. The problem with changing these values is you would expect it to be sensitive enough to change your voltage values incrementally, like from 1 volt to 1.1, 1.2, 1.3. This software is not that complicated. So if I do slider, it changes it in a coarse mode. It changes the value to higher values or lower values in a coarse mode, meaning you're not going to have a point value or a fine adjustment. So those numbers moving, that's a coarse adjustment. But if I wanted to get it fine, I have to go in and I have to type the value to exactly what I want. So you have an advantage with the software. It's going to help you a little bit.
Okay.
Help you with some of your formulas.
So
All
that's
right,
a very
thanks a
good
lot,
tool.
thanks a lot.
Very
Okay.
good tool for designer.
There's some quirks here and there. You got to figure it out. Just remember your list for your components, and then saving your file for export, either a link or a text, and save frequently. Because once you make a change, like say if I do a, let's see if I can ruin this real quick. Let's say if you have a power outage or your computer burps or you might have a bandwidth issue, this software will erase your schematic. That's why I say save it often because your whole screen will get erased. All right, that's all I wanted to help.
Okay, thank you, Luke.
You're welcome.
Okay, today we will be soon will be end. Okay. However, make sure tomorrow you have to download tomorrow for about 30 minutes. I will talking about the quiz number 2. Then we go with the electronic. Okay. E-handout diode. So make sure you download both. Ready for tomorrow. Okay, so any more question? Anything else? If it's not, then we will end for this meeting today.
What about the multi-sim? Do we get access to it for download, or we just download the trial one?
You mean the PSpice or what?
Yeah, the multi-sim PSpice.
Yeah. So Mr. Tai will talk to you.
Oh, okay, thanks.
Hey, Mr. Pham, he said two things there. Multisim and PSpice are two different things. So I know we're going to be doing PSpice, but are you going to do anything with multisim?
No, multi-sim will be doing in the classroom.
Okay.
We don't have permission.
Okay.
Are we going
Only
back anytime
PSpice.
soon?
What?
Are we going back anytime soon?
Yeah, I believe so, but who knows what happen.
Okay, that sounds good.
Okay, when we going back to the classroom, you still online for lecture with me. However, take one only one day Monday, take two only one day Tuesday.
I don't think the classes are opening at all.
Yeah, right now
until
it's
at least
hard to
spring.
say.
Yeah, no, that's not going to happen.
Yeah,
They had a guy on the internet that said the whole semester going to be like this.
Yes, the whole year.
we'll see. Okay.
Yeah, I don't think. Quick question, Mr.
Yeah.
Pham. I'm so sorry. On Friday, had a question on whether that will be on YouTube or not. Friday's lecture.
You
Anybody
mean,
knows?
You mean question for me?
Yeah. Do you know?
Then
Maybe Sam.
You can ask me anytime.
Okay.
Only thing you have to text to me, so I can get in Zoom with you.
Okay. Thank you.
Okay. Anyone not quite understand, then you can text to me. Sometimes we just about 15 minutes or 30 minutes and get everything done.
Okay.
If you don't know, don't try to do it. The thing is, if you don't know what happened, You must be understand. And basically, I'm not go anywhere. I stay home. So that's
So
why.
Monday through Thursday here, and if we got a question, we could just text you on a Friday or something, and then
Anytime.
yeah, right. Gotcha.
Saturday, Sunday.
But before 3 a.m., right?
Okay, so good night.
Good night.
Thank
for
you.
your time.